Okay, part two, we're going to talk about acid rain. Because of the chemical reactions that are involved in the formation of greenhouse gases, as well as acid rain on the burning of fossil fuels, which is got to do with the emission from cars as well. That ties into this link very well. For that bit, you need to be gathering information. I've got a few activities online for you anyway. But remember, Environmental Protection Authority is a good one. Have a look at photochemical pollutants, nitrogen dioxide. And just to let you know, the federal government developed a test for diesel emissions from cars and trucks in September 2000. It could dramatically improve air quality in Australia's cities, and it already is beginning to, as now we are more aware, we can solve the problems. Okay, so acid rain is produced primarily by the release of sulfur oxides and nitrogen oxides into the atmosphere. These oxides are emitted from electrical generating plants, industrial boilers, and large smelters where fossil fuels are burnt in large amounts. The countryside around Queenstown in Tasmania has been described as a moonscape because of the lack of vegetation. This vegetation was killed off by the action of acid rain, which resulted from mining operations in the area. For environmental reasons, mining in this area has been stopped and vegetation is slowly returning to the area. Acid rain can have very serious effects on the environment. Soils become acidic, leaves of plants are burnt, waterways become acidic and injure or kill aquatic life. Humans can be affected and building made of limestone or marble can become corroded. And we can also produce chemical smog. Nitric oxide starts a chain reaction with sunlight, water, vapor, hydrocarbon, resulting in over 100 types of secondary pollutants. So what fueled the Industrial Revolution? Let's have a look at combustion reactions. So, combustion of carbon, which is coal, and hydrocarbons, which are petroleum and natural gas, so got to know the difference, in fossil fuels is the major source of greenhouse gases, which are CO2 and CO, which is carbon monoxide. Mono as in one, like monobrow. So, combination reactions with oxygen, as you know, they always produce oxides. So, for example, carbon plus oxygen gives you carbon dioxide. Fuels are substances that release a lot of energy as heat when combusted. Examples of fuels include coal, petroleum, and natural gas. So when there's no H in it, it's just a carbon. When there's CH4 or there's other varieties, it's called a hydrocarbon. So many fuels are hydrocarbons, they contain the element hydrogen. So, the combustion of hydrocarbons produce oxides and carbon. Oh, sorry, one of the first, where is it? So this is like the first type of reaction. C plus O2 gives you CO2. This is called, this is a type of complete combustion. Now let's have a look at the reactions of hydrocarbons. They produce oxides of carbon and oxides of hydrogen. CH4, which is methane, plus oxygen gives us carbon dioxide plus dihydrogen oxide. To put it simply, fuel plus oxygen gives us carbon dioxide plus water plus energy, which comes off as heat. Carbon dioxide is a greenhouse gas, so the combustion of that fuel causes CO2 to be formed. The other types of reactions so basically, this is a complete combustion when we produce carbon dioxide. So when we have carbon monoxide formed, then it is incomplete combustion. So carbon and oxygen gives us carbon dioxide, complete combustion. Hydrocarbon plus oxygen giving us carbon dioxide and water is also complete combustion. And our incomplete combustion reactions are carbon and oxygen, giving us carbon monoxide, and hydrocarbon plus oxygen, giving us carbon monoxide plus water. Okay? Fossil fuels aren't pure hydrocarbons. So, coal and petrol contain other compounds like sulfur compounds. This is step 1 in acid rain production, which is the sulfur plus oxygen gives us sulfur dioxide. Same as nitrogen plus oxygen giving us nitrogen dioxide. So sulfur dioxide and nitrogen dioxide both react with water to form an acid, either sulfuric acid or nitric acid. And this is the combination from the elements that are mixed with coal and petrol. If we were to mix trioxide plus water, we would get sulfuric acid as well as nitrogen trioxide. And carbon dioxide plus water will also give us carbonic acid. So, where does the vehicle oxygen come from for the combustion in fuels inside the vehicle engines? Apart from oxygen, what other gases are in the air? An unintended consequence of combustion in engines is the production of other oxides. So, nitrogen gas plus oxygen giving us nitrogen dioxide. Global warming refers to an increase in the Earth's temperature due to such things as burning fossil fuels and other industrial processes and agricultural processes, which builds up greenhouse gases in the atmosphere. This phenomenon is a highly debated issue. There has been much emphasis in recent times on the cause of global warming. 3 viewpoints stand out. Global warming is enhanced by human activity. Global warming is a natural fluctuating process. Global warming is a false phenomena created by poor measurement and analysis of statistics. Most scientists in the climate change field believe that rises in CO2 emissions have been directly responsible for rises in global temperature. However, there are some scientists who argue that this temperature rise could just be a part of natural fluctuations in the absorption and emission of such things such as methane gas. And there are a number of views on the cause of global warming. Greenhouse gases normally surround the Earth, keeping it 33 degrees warmer than if it were not present. This is the natural greenhouse effect which enables life to survive on Earth. It's believed that natural processes such as weathering, volcanic activity, respiration, photosynthesis, and decomposition produce just enough of these gases to enable our planet to support life. One of the reasons is carbon dioxide. So the increase of burning of fossil fuels and widespread deforestation have caused greenhouse gases to dramatically build up in the atmosphere. As we looked at the equation, carbon dioxide is a result of burning fossil fuels. Since 1850, there's been a mean rise in global temperature of approximately 0.74 to 0.18 degrees Celsius, with most of this increase since 1960. 0.74 degrees plus or minus 0.2. Okay? Carbon dioxide levels have risen from 280 parts per million in 1850 to 375 parts per million in 2004. Since the Industrial Revolution, human activities have seen massive amounts of fossil fuel being burnt to generate electricity, fuel furnaces, and operate smelters. This, combined with the burning of fuel in motor vehicles, has resulted in a massive amount of CO2 being emitted into the atmosphere. Due to the greenhouse effect of CO2, many scientists link the rise in global temperature to the increase in CO2 levels. So, as seen here in this image. If this is a real phenomenon, predictions of what the future might look like are kind of daunting. High global temps, changing climates, rainfall patterns would alter, affecting agriculture and also natural environmental flows. Patterns of droughts and floods would be disrupted. Ice caps would melt, sea levels would rise, heat-related health problems would increase. Hotter climates would encourage the spread of disease. Some scientists believe that global warming is a natural process that happens between ice ages, resulting from the following geological events. Volcanic outgassing. If large amounts of volcanic activity were to occur, it would change global temperature dramatically. And we've had a look at this, and we know that this is something that doesn't last very long. It's more of a temporary change. And also plate convergence, producing mountains, which would increase the rate of weathering, releasing large quantities of CO2 into the atmosphere from the breakdown of minerals. So other scientists believe the greenhouse effect is statistically false, a skewed interpretation of data. The debate remains as to what is causing global warming. What do you think? I have a few. I also want to quickly talk about methane as the cause. That's another reason. Given that methane has 11 times more warming potential than CO2, processes affecting the release should be given great consideration. So some of these come straight from nature, which are called clathrates. They occur as a result of organic matter decomposing, and the methane that results becoming entrapped. Most of the methane gas is trapped in ocean sediment. However, some methane that's trapped in ice in Arctic regions and in the tundra. Worldwide amounts of carbon bound in clathrates are conservatively estimated to be total twice the amount of carbon to be found in all known fossil fuels. The methane that's trapped can be released into the atmosphere. This is happening as the sheets are melting and as the sea are melting, or in the case of clathrates, layers in the ocean sediments, the pressure of the water above them is reduced. It is very important. It's very difficult to tell and predict the effect of climate due to the large number of variables that are involved with the greenhouse effect. So things like climate cover, cloud cover, or volcanic activity. As we know, clouds and little particles or aerosols in the air reflect incoming light, and they absorb outgoing infrared radiation. The magnitude of its effect depends upon the degree of cloud cover, its altitude and thickness. Scientists view the effect of cloud cover varying from no greenhouse effect to an average of 2 degrees Celsius temperature rise over 100 years. Okay. And although even though it's hard to predict, there are a number of global climate models that have been developed that assist scientists to make predictions about the effects of global warming. However, there is concern by some scientists that these models may not be accurate enough for policymakers to determine what actions should be taken. Most importantly, what is being done to stop global warming? Increased global temperatures has prompted government agencies and industry, both nationally and internationally, to protect the environment, specifically the atmosphere and the hydrosphere. Most people believe it is impossible to make a significant difference to our environment and that we can all be involved in its improvement. So what's being done? To say that nations should stop emissions altogether would be unrealistic. However, emissions cannot continue at the present rate for reasons we've already had a look at. This makes it very difficult to determine by how much emissions can be reduced without having a negative economic growth for each individual nation.